Hi everyone, let's do some example exercises for chapter 11. The first example exercise deals with opportunity cost, and that is the cost of what you're giving up by choosing to do something else instead. In this case, Best Trim, who manufactures lawnmowers, is going to have a decision to make when it comes to purchasing. They call this the economic order quantity. What is the proper amount of inventory to order at any one given time? Because there's an opportunity cost involved. If they order a lot of inventory, they're going to tie up a lot of money in inventory, and they can't use that money to do something else. So let's look through the numbers that we have here. They think they're going to need 204,000 spark plugs next year for production of lawnmowers, and they estimate that it's going to be a pretty even distribution of about 17,000 spark plugs per month. Their supplier says that they're going to sell them spark plugs for $9 per plug, but if they order a full year's worth of 204,000 spark plugs for the whole year at once, they'll give them 2% off that $9 price, so each spark plug will be cheaper. However, Best Trim would have to put in more money to buy that huge quantity, and if they do so, they're going to be giving up the potential to get a return on their investment. They're going to have their cash tied up in spark plugs and not be able to invest it in the market or whatever. If they were to invest that cash, they would return 10%. And then lastly, last piece of information for this question, it costs Best Trim $260 processing for each purchase order that the company fills out. So that's a whole lot of information. Let's parse it down, make some tables here, find all the numbers that we are going to need. So they have two alternatives in this case. They can continue to order monthly at about 17,000 units a month and pay the $9 per spark plug by doing so. Or they can go and they can buy an entire year's worth at once, and their supplier will give them a discount, and they won't have to pay the full $9. They'll get 2% off. So they'll be paying essentially 98% of that $9 for each spark plug, which comes out to be $8.82. So we have our unit cost of each alternative. Well, how many units are they going to purchase at a time? 17,000 if they order every month at a cost of $9 per spark plug, means that each month they're going to have to lay out $153,000 in cash to acquire that month's spark plugs. If they order annually, they're going to buy all 204,000 for the year at once, but they're only going to pay $882 per spark plug, which means they're only going to make one purchase a year, but that purchase is going to be expensive. How expensive? $1,799,280 it's going to cost to buy 204,000 spark plugs for the manufacturing of these lawnmowers. And something else that we're going to need for our computations is called our average investment in inventory. And we're going to operate under the assumption that Best Trim purchases the absolute perfect amount of spark plugs, where at the beginning of the period they have the full size of their purchase. It'll be 17,000 if they order monthly and 204,000 if they order annually. And then at the end of the period, they're going to be out. Like, they bought the perfect amount of spark plugs where they run out with the very last one that they need each year. Well, that means that they would have all of the inventory on hand on the first day and none left on the last day. We want to find the average amount they would have on any one given day. Well, it's easy enough. Assume that what they'll have on the last day, their lowest day, the like high-low method, is going to be 0, and high is going to be what the purchase costs. You can just find this by dividing your inventory costs by 2. So their average investment in inventory, if they purchase monthly, is going to be $76,500. They'll have $153,000 on the first day, 0 on the last day. You add them together, you divide by 2, it's $76,500 on any given day. And their average investment in inventory, if they make annual purchases, is going to be half of that gigantic purchase cost. It'll be $899,640. And with that, we can figure out all of the relevant costs of purchasing. So let's start with ordering monthly. What will the annual purchase order cost be? Well, we know that it's $260 per purchase order. But if they order monthly, they're going to have to pay this 12 times. They're going to pay it every month for the entire year, which means they're going to spend $3,120 in processing fees for purchase orders during the year. If they order annually, well, they only have to pay it once. It's just one purchase order for that whole gigantic amount of spark plugs. So they only have to pay $260 in purchase order processing fees, which means that by ordering monthly, they have to pay an extra $2,860 during the year in purchase order costs in order to obtain these spark plugs. What will their annual purchase cost be? Well, we already figured out over here that if they order monthly, it's $153,000 per month, which means their annual purchase cost is going to be that $153,000 times 12, or $1,836,000 they're going to spend acquiring spark plugs. If they order annually, they're going to make one purchase, and that one purchase is going to cost $1,799,280, which means by ordering monthly and foregoing that 2% discount, they're going to end up spending an extra $36,720 on those spark plugs during the year. So everything we're looking at right now looks like ordering annually is the better option, right? We spend less in purchase order costs, we spend less per unit for the spark plugs, which means our annual purchase costs are going to be significantly lower, like $36,000 plus lower. We got to take into consideration the fact that if we do that, we are tying up a ton of money throughout the whole year in inventory that's just going to be sitting around getting waited to use for the entire period. We're giving up something. We're giving up the ability to invest any extra cash we have and return 10% per year, which is how we're going to figure out our opportunity cost. We had to figure out that average investment in inventory earlier. Well, let's take the average investment in inventory and multiply it by the rate of return that we would have if we put it into the market instead of using that cash to buy spark plugs. So our average investment in inventory, if we order monthly, would be $76,500. Well, let's multiply that by our rate of return on the investment, which was 10%, which means we're foregoing about $7,650 worth of possible returns on the market. If we took all of our money and put it in the market, we're giving up $7,650 by spending some of it to order monthly. However, if we order annually, we're going to give up $89,964 in possible returns by investing this money instead of buying spark plugs with it, which means that our opportunity cost, if we order monthly, we're foregoing $82,314 less possible investment return. So our relevant cost for ordering monthly is just the sum of those numbers, $1,846,770. If we order annually, it's $1,889,504, which means that our relevant costs for the year of making monthly orders is actually $42,734 less than it would be to order annually. So why? We already know that we'll pay less in purchase orders if we order annually. We already know that we'll spend less per unit on spark plugs and therefore have a lower annual purchase cost. But by tying up all of that money, we're not allowed to get that 10% return by putting any excess cash we would save by making a smaller purchase each month into the market and returning money off of it. So essentially what is happening here is Best Trim is better off making the smaller purchase, using that free cash flow that they have to invest it, and taking that return on their partial investment than they are saving the 2% by buying all of them at once. So what is the best method here? They should still order monthly because their returns on the market are going to offset any losses they would have for any savings foregone by making this one big huge purchase. In exercise 2, we're going to move on to a concept called constraints, and everybody has them in life. Our things that we enjoy doing, our hobbies, are constrained by how much we can afford them. Everybody has to deal with constraints. And for a business, there's a lot of things that you're constrained by, but a big one is customer demand, right? There's no reason to make a ton of units just because theoretically they'll be super profitable if you can't sell them. So you're constrained by how many units you think you can actually push to your customers. Another thing that companies are constantly constrained by is their production capabilities. There's only so many machines. There's only so many employees that know how to run those machines. So you're constrained by what you have the capacity to actually make, and you're also constrained by what you could sell after you make it. Old Boy Pizza, in this example, has both of those problems. They make different oven-ready frozen pizzas, and they come in 3 different brands, and they are the Bite Size, the Personal Pan, and the Supreme. Their research says that they think they can sell 10,000 bite-sized pizzas, 4,000 Personal Pan pizzas, and 3,000 Supreme pizzas during the year. So they're constrained by their customer demand. There's no reason to make a 3,000 and first Supreme pizza because they don't think that they will sell it. They're also constrained by how much they can make. It takes machine hours to produce these pizzas. They're frozen pizzas, so they're probably pretty manufactured. They only have 1,300 machine hours for the month. That's all of the time that they have based on the quantity of machines they have and skillful people that know how to operate those machines. It takes 0.05 hours to produce a package of bite-sized pizzas. It takes 0.1 hours to produce a package of Personal Pan pizzas, and it takes 0.2 hours to produce a package of Supreme pizzas. So what do we make first? Well, we have already come across the concept that what we want to do is maximize our contribution margin. Like, if we have the option of making different products, we're obviously going to make the product that is most profitable to us. So what is our unit contribution margin for our 3 different brands? Well, we have this information given. Bite Size sells for $2. It costs about $1.60 to make, which means its unit contribution margin, each package of bite-sized frozen pizzas that we sell, contributes about 40 cents towards paying our fixed costs. The Personal Pan sells for $3.20. It costs $2.24 to make, which means that each bag of Personal Pan pizzas that we sell is going to contribute 96 cents towards paying our fixed costs. And for the Supreme, it sells at $6. Its unit variable cost is $3.75, which means it has a unit contribution margin of $2.25. So just looking at that, you're thinking, why don't we just make all Supreme pizzas? It has the highest unit contribution margin. Well, that's true, but it also takes the longest time in terms of machine hours to produce, and that's one of the things we're constrained by. We're constrained by how many hours we have to produce. So if the hours required to produce 1 unit are 0.05 for bite size, 0.1 for Personal Pans, and 0.2 for Supremes, let's fill in that information. And we can use that to figure out how many pizzas we can produce an hour. And all we have to do for that is take 1 and divide it by our hours required to produce 1 unit. If it takes 0.05 hours to produce 1 package of bite-sized pizzas, we can make about 20 of them an hour. If it takes, if you will, 1/10 of an hour to make a Personal Pan pizza, that means we can make 10 an hour. And if it takes 0.20 hours to make a package of Supreme pizzas, it means we can make 5 packages per hour. Well, let's take our unit contribution margin for each one of these, which we've already found to be 40 cents for the bite size, 96 cents for the Personal Pan, and $2.25 for the Supreme. And we're going to go through and we're going to multiply that by how many we could produce per hour. See, we're constrained by machine hours. We're constrained by how much production capacity we have. So we shouldn't be looking at what is the most profitable thing bag per bag, because we're not constrained by that. We should look at what's the most profitable thing, what is the highest contribution margin we can have per unit of our constraint. So for each hour that we run machines, if we made bite size, we'd have a total contribution margin of $8. It'd be 40 cents per bag, and we can make 20 bags. For Personal Pan, it's 96 cents per package. We can make 10 of them, which means our contribution margin per each machine hour per unit of our constraint is $9.60. And then for Supreme, we can make 5 of them an hour, but each one has a whopping unit contribution margin in comparison to our other products of $2.25, which means the Supreme Pizza has a contribution margin of $11.25 per machine hour. What does this all mean? Let's look at our constraints. The maximum amount of demand that we have is 10,000 packages of the bite size, 4,000 packages of the Personal Pan, and 3,000 packages of the Supreme. We know how long it takes to make each one of those, which means if we went through and we made all 10,000 of those bite-sized packages, each one taking 0.05 hours to make, it would take us 500 hours to produce that maximum demand that we had. Our machine hours at max capacity for that particular line would be 500. Doing the same math for the Personal Pan and Supreme, taking our maximum demand in units for that particular model and multiplying it by how long it takes to produce each unit, tells us it would take us 400 hours to produce all of those Personal Pan pizzas, and 600 hours to produce all of the Supreme pizzas. Well, we got a problem right now, because if you add that up, 600 hours for Supreme, 400 for personal pan, and 500 for bite size, that's 1,500 machine hours it would take to make all of those. Well, we only have 1,300 machine hours worth of capacity, so we can't make all of the pizzas we think we could sell. How are we going to decide which ones to make first? It's easy enough. You go with what has the highest contribution margin per unit of your constraint, per machine hour in this case. Since Supreme's the highest, we're going to make those first until we made so many that we don't think we could sell anymore if we made it, until we meet that maximum demand. In which case, we're going to move on to the second best thing we have. And the second best thing we have is personal pan pizza. And then, if we've gone through and we've made as many of those as we think we could reasonably sell, then we'll move on down the line to what has the next highest contribution margin per unit of our constraint, which is the bite-sized pizza. So when you have a product mix that is constrained, that's how you roll with it. You figure out what your contribution margin is per your unit of constraint, and then allocate it out to the models that produce the highest contribution margin per unit of your constraint first, all the way down the line until you've spread out how many machine hours, in this case, how many units of your constraint you have. So now that we have this information, we can figure out what's going to go to what. So our total capacity was 1,300 machine hours. Well, we know the Supreme is the best thing for us to make because it has the highest contribution margin per machine hour, which means we should allocate as many possible hours as we can to it until we meet that maximum demand. And we've already determined that was 600 hours. So our capacity remaining after we've made those would be 700. We're going to move on to what is the second best thing for us to produce, and that's the personal pan pizza. To produce all 4,000 of those that we think we could sell, it's going to take 400 hours. So we got that much left. Let's send out 400 hours to the personal pan pizza, which means we have 300 hours of capacity remaining. Well, what should we do with this? Well, the bite size, even though it's the least profitable, is still a profitable line. So let's go through and let's allocate that full 300 remaining machine hours to the bite size brand line. And now we can go through and we can determine what our company's maximum total contribution margin is. For each different line, we're going to go through and we're going to take our contribution margin per unit of our constraint per machine hour that we found earlier. $8 for the bite size, $9.60 for the personal pan, and $11.25 for the Supreme. And we're going to spread it out and multiply it by how many hours we're going to allocate to production of that particular model. We determined last slide, we're going to put 600 hours into the Supreme, 400 hours into the personal pan, and 300 hours into the bite size, which means our total contribution margin from the bite size is going to be 2,400. Our personal pan is going to have a contribution margin of $3,840, and the Supreme pizza line is going to give us a contribution margin of $6,750. And in total, we're going to have a total contribution margin from the production of these three different pizza lines during the period of $12,990. That is the maximum amount we can get given our two constraints, how many of each unit we think we can sell and how many machine hours we have for production. And in exercise 3, we're going to use a little bit of algebra to help us out in this situation. So Della Simpson Incorporated sells two popular brands of cookies. They have Della's Delights and they have Bonnie's Bourbons. Both cookies go through the mixing and baking departments. That's what you got to do to make cookies. And their vice president for sales believes that at the current price, they could sell all of the daily production for both of them. So they're not constrained by customer demand. We're doing this question algebraically, so let's keep it simple. Don't want to have too many different constraints to work with. We have information below about the company's mixing and baking requirements, as well as the sales information for each of the product lines. So we have our two lines. We have Della's Delight and we have Bonnie's Bourbon. Well, the Della's Delights, they take half an hour to mix each batch, and then it takes 10 minutes to bake each batch. For Bonnie's Bourbons, it takes 15 minutes to mix, and it takes 15 minutes to bake. Well, we're constrained by how much we have in our two different departments. We only have 660 minutes to put into mixing. We only have 300 minutes to put into baking, which means we need to figure out given that information, what is the best mix we can make of Della's Delights and Bonnie's Bourbons? And again, we know about our contribution margin being the thing that drives our decision, so let's look at that real fast. Each batch of Della's Delights that we make is going to give us revenue of $4.75, and it's going to give us variable costs of $1 or $175, meaning that our contribution margin per each batch of Della's Delights that we make is going to be $300. For Bonnie's, it has a revenue per batch of $3.75. Our variable cost per batch is $1.25, which means each batch of Bonnie's bourbon cookies that we make is going to have a contribution margin per batch of $2.50. So with that information, we can figure out what is our optimal mix later. How are we going to do this? We're going to use some good old algebra to figure out what our optimal mix is. The first thing we need to do is establish a formula for each department, because we're constrained by the hours available in each department. So in the mixing department, we know that Della's Delights takes 30 minutes to mix. We know that Bonnie's Bourbons takes 15 minutes to mix, and we know that the total amount of minutes available from the mixing department each day is 660 minutes. Well, let's set that up as a formula. 30D plus 15B equals 660. So I used D and B for Della's and Bonnie's as the variables, and then it's how many minutes each one takes is the coefficient in front of that variable, and at the end of our equation we're going to have it be equal to the number of minutes that we're constrained by, the number of minutes that department has per day. So that is the one for the mixing department. What would it be for the baking department? Same exact concept. We're going to take how many minutes it takes to make a Della's. It takes 10 minutes, so we'll call that 10D. It takes 15 minutes to bake a batch of Bonnie's Bourbon, so we'll call that 15B, and then it's equal to the total amount of minutes available from the baking department a day, which is 300. So our formula for baking is 10D plus 15B equals 300. And now we can figure out our mix by using a thing called elimination by addition. And what you have to do in this is figure out what you have to multiply one of your two equations by, so that when you add your equations together, one of the variables goes away. So what I did here is the baking formula of 10D plus 15B equals 300. I multiplied it by -1. So when we add it together, the 15B from the mixing formula and the -15B now from the baking formula, they cancel out. And as we solve for this going through, we see that we get D equals 18 as our answer. That means that optimally we should be making 18 batches of Della's Delights. Well, let's take that first variable we solve for and let's sub it into the other equation, or one of the equations, to solve for the other variable. And I used the equation for the baking department. See, we know that D now is 18 because we just solved for it. So 10D plus 15B equals 300. We substitute 18 in for D, and we come up with B equals 8. So using this elimination by addition, we came up with D equals 18, B equals 8. And what that is our optimal mix. Our optimal mix is to make 18 batches of Della's Delights and 8 batches of Bonnie's Bourbons. Let's check it out to make sure our numbers work out. If we go through with this mix and we take the number of minutes it takes to make each batch in each respective department and multiply it by the optimal number of batches to make for that one, we should max out in each department. So Della's Delights, we determined the optimal mix is 18 batches. Well, if we multiply that by how many minutes it takes to mix, in this case Della's Delights, we should get amount of minutes that it's going to take to make that optimal batches within that department. It's 18 batches. It takes 30 minutes to make each batch, which means that in the mixing department it's going to take a total of 540 minutes to make Della's Delights. Della's Delights take 10 minutes per batch to bake. We're going to make 18 of those, which means in total it's going to be 180 minutes to bake those Della's Delights. For Bonnie Bourbons, we went through and we figured out that 8 is our optimal amount to make in our product mix. So let's take that 8 and multiply it by how many minutes it takes to mix each batch. 8 batches at 15 minutes per batch means it's going to take us 120 minutes in total to make those Bonnie's Bourbons. And because baking also takes 15 minutes, that's also going to take 120 minutes in total to bake all the Bonnie's Bourbons. And when we add those together, we get 660 minutes in the mixing department and 300 minutes in the baking department, which is our constraint. It's our total available per day for each department. So when we did indeed go through and found out what was the best way to use our time, it is to make 18 batches of Della's Delights and 8 batches of Bonnie's Bourbons. And if we do that, well, what's our contribution margin going to be? Well, we just take the batch amount and multiply it by the number of batches. So for Della's, each batch is $475 in revenue. We're going to make 18 of them, which means that would be $8,550 in revenue. For Bonnie's, each batch makes $375 in revenues. We're going to make 8 of them, so 375 times 8 means $3,000 in revenue. We're going to do the same thing for variable cost. $175 is our cost to produce each batch of Della's. Well, if we make 18 of them, that's going to be $3,150. And using that same process, Bonnie's is going to cost us $1,000 to make those 8 batches at $125 per batch. So our contribution margin from Della's each day is going to be $5,400, and from Bonnie's it's going to be $2,000. And we're going to have a total contribution margin of $7,400. Now it seems crazy, but you can go and you can throw in any amount of numbers that you want. You will never find a higher contribution margin without exceeding the minute constraints for either of the two departments.